Hello everyone, welcome back. So in today's lesson, what I'm going to cover is the areas of similar shapes. So far what we've covered is similar triangles and how the sides of similar triangles are in proportion. Now today we're going to cover, instead of the sides, we're going to cover the area. And you will find that there's a relationship as well. So just to give you a recap, we're going to actually do some similarity between non-triangle shapes as well. So let's just take a look at 10.02, the prep quiz. Now the first one says the rectangles are similar because, well, the one on the outside is a bigger version of the one on the inside. Find the ratio of AD to EH. So let's just take a look. So what's the AD? AD is 5y. And the EH is 3y. Right, so the ratio is 5y to 3y, and we can just divide both by y, so we get 5 to 3. Right, now that's the ratio of the sides. Now the next question says, find the ratio of the area ABCD to the area EFGH. Okay, so let's try that. So what's the area of ABCD? Well, the area is basically base times height, right? So in this case, 5y times 5x, which is 25xy. Now what's the area of the smaller rectangle on the inside? So that's 3y times 3x, which is 9xy. So how do we simplify this? Well, we can divide them both by xy, so we're left with 25 to 9. Now, look at these two ratios. This is the ratio of the sides, and this is the ratio of the areas. What do you notice? Well, the first thing I notice is that the ratio of the areas seems to be the squared values of the ratio of the sides, right? If I square the 5, I get the 25. If I square the 3, I get the 9. Right? So that seems to work. Let's do another example. So question 3. The triangles are similar, so that's something we're familiar with. Find the ratio of PQ to TR. PQ to TR is A to B. Now the area of triangle PQR. So what's the area of triangle PQR? So that's going to be what? Half times base times height. So half of A squared to what? Half of B squared, right? If we want to simplify this, we can divide both by half, so we get A squared to B squared. So if you look over here, the ratio of the sides is A to B. The ratio of the areas is A squared to B squared. So you would learn that from this exercise that the ratio of the areas is basically the squared version of the ratio of the sides. And that's basically all you have to know for the exercises. In the prep quiz, we investigated the relationship between sides of similar figures and the areas of those same figures. For the rectangles, if the ratio of sides is 5 to 3, then the ratio of areas is 5 squared to 3 squared. So in this case, 25 to 9. For the triangle example, A to B was the ratio of the sides. Ratio of the areas is A squared to B squared. So that's the property that you've learned here. If the ratio of matching sides is A to B, then the ratio of areas is A squared to B squared. The areas of similar figures are proportional to the squares on matching sides. Yes, okay. Alright then, so that should be pretty straightforward. So I'm just going to go through two examples. And the examples I'm going to go through, as you probably would have guessed, are the ones from here. So let's take a look. Make it a bit bigger. So, okay, the pages of two morning papers are similar in shape, and the width are in the ratio of 3 to 5. Find the area of the larger page if the smaller one has an area of 1080. Okay, so that means we know that the ratio of the sides are what? And the width are in the ratio of 3 to 5. So the ratio of the sides is 3 to 5. So ratio of sides. So then what should the ratios of the areas be? Well, it should be those numbers squared. So then it should be 9 to 25. So that should be the ratio of the areas. Now the question says, find the area of the larger page if the smaller one has an area of 1080. So then basically we know that 1080 will represent the smaller one. And it's asking you to find the area of the larger one, right? So the 1080 matches with the 9. What should match with the 25? So to find out x, there's a few ways you can do it. So I recommend the cross method, which is very straightforward. You just have to do 1080 times 25 divided by 9. So that should give you, okay, well, let's work it out. X equals to 1080 times 25 divided by 9. So that should be, I think it should be 300, but let me just double check. 1080 divided by 9 times 25. Oh, sorry, not 300, 3000, yep. Okay, so then the area of the larger page should be 3000 centimeters squared, right? So that's pretty straightforward. Let's take a look at the next question. Now, most of these questions aren't going to be too hard, so you should be able to do them pretty easily. Let's take a look, move it here. Okay. All right. So it says 2 similar stickers of boomerangs were produced for Australia Day celebrations. The area of the larger sticker is 1108. If the area of the smaller one is 48, and the area of the smaller is 48. If the length of the larger is 48, find the length of the smaller. Okay. So then what we do is we find the ratio of the areas first. The ratio of the areas is 48 to 108. Now, can we simplify this? Well, yes, we can. So what's 48 divided by 108 simplifies to? You can use a calculator for this to simplify the ratios. So 48 divided by 108. So that would be 4 to 9, right? 4 to 9 is the ratio of the areas. Now, what should the ratios of the sides be? Well, you just square root both numbers, right? Because we have ratio of areas. To go from ratio of areas to ratio of sides, you square root them. Okay, now the question says, if the length of the larger is 18 centimeters, find the length of the smaller. So that means, because this is the larger one, so you just say x to 18, right? So basically 2 to 3 equals to x to 18. What's x? Okay, well that's pretty easy. X is just equal to, you can use the cross method again. Just do x is equal to 2 times 18 divided by 3, which equals to 12 centimeters. Voila. That's how you get the answer. And let's check the answers. It's 12 centimeters and 3000 centimeters squared. Okay. So that's, so far the questions have been pretty straightforward. I'm just going to pick some questions from the homework just so that you get a better understanding. So let's just take a look at what's in the homework. In each of the following, the figures are similar. Find the ratio of the small area to the larger. Okay, so that's pretty easy. So just take a look. Question C. You know the ratio of the sides is 8 to 5. So then the ratio of the smaller area to the larger. So that's just going to be 25 to 64, right? All right, so I'll pick some of the harder questions just so that you get a better understanding. So let's take a look at question 5, okay? So, oops. Okay, let's take a look. Okay, so the matching sides of 2 similar kites are in the ratio of this. Find the area of the smaller, if the larger area is this. Okay, so that's pretty standard. So the ratio of sides is what, 11 to 16? Yep. So ratio of sides. Okay, you can just say R sides. So then what should the areas be then? So what's 11 squared? 221. 16 squared is 256, right? So that's the ratio of the areas. Now the question says find the area of the smaller one if the larger one has an area of 1.44. So that means you want to find the smaller one. And if the larger one is 1.44, how do you find x? So then x is equal to, use the cross method again. So x equals to 121 times 1.44 divided by 256, which equals to, let's take a look. So 121 times 1.44 divided by 256, 0.68. So then 0.68 meters squared to dp, right? Because there's actually quite a lot of decimal points after this. All right. I'll do one more question and then I'll wrap it up. So let's take a look at question 7. All right. So what is question 7? Good thing there's no red questions in this exercise. My neighbor, whose lawn is a similar shape to mine but has dimensions 2/3 as large. So that means it's actually 2/3 smaller. Was surprised to hear that I used 90 kilogram of ammonium sulfate to treat my lawn. How much would be need to treat his lawn the same way? Okay. So to do this question, what we can do is we can just draw a diagram, okay? So now we don't actually know what shape it is, okay? Just pretend it's, I don't know, pretend it's like a rectangle. So say this is my lawn and this is my neighbor's lawn. My neighbor's lawn. So then just assume my dimensions are, say, x by y, right? And his dimensions are 2/3 as large. So let's just say 2/3 x to 2/3 y. Right? So then what should the ratios of the areas be? The ratio of the area should be xy to 4 and 9 xy, right? So that's the ratio of the area. And if you simplify this, it's actually 1 to 4 and 9 if you divide both sides by the xy. And this can be simplified to, if you times both sides by 9, you get 9 to 4. Okay, so that's the ratio of the area. Now it says, was surprised to hear that I used 90 kilograms of ammonium sulfate to treat my own. Now that means that I used 90 kilograms of ammonium sulfate. How much would he need to use? Right. So then basically you just find x. So then just use the cross method. So then you have x is equal to 90 times 4 divided by 9, which gives you 40 kilograms. And that's your answer. Alright, so that should be all for today. Thank you for listening.